to meet the changing demands of the society using the technology which is developing at higher pace. Today, there are a lot of engineering applications are being developed due to a lot of innovations are happening and a lot of technological interventions are taking place. So today we are going to discuss applications of smart engineering and which are leading for a sustainable future through innovation. So here we are having a practicing engineer. So he is putting his efforts in making people to learn and making students to have their future careers in right direction with us. So engineer TVN is with us. And on behalf of Board for Community Development through Education, we are also conducting few activities uh, 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 targeting the students, higher education students, to have awareness on sustainability and development and making them involved in so many socially relevant projects and community service projects and making them available for the benefit of the governments and for the benefit of the institutions and for the benefit of society. So, friends, so we are come to the a juncture where it is inevitable to use the latest technologies, especially IoT and artificial intelligence and digital twins, and so many things are happening at very higher pace. So without using all these things, we cannot survive, and our systems cannot be perfect at this juncture. So, being engineers, we should lead the world in implementing these technologies, and especially engineering students who are budding engineers. They are uh, 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 they are bound to learn these things, and they are bound to lead our country and lead our nation and lead our world uh, for the sustainability for, through their latest developments and designs and practices which they are going to take part in down the line. So now at this juncture, I must congratulate all the state committee members of Andhra Pradesh Institution of Engineers and coordinators of Board for Community Development and Education for making this possible and convening this meeting. So I wish these deliberations will be a great fruitful results, and especially budding engineers will get a lot of inputs and useful content from our speaker. So thank you for giving the opportunity. Over to organizers.
Thank you, sir. Now it's my proud privilege to introduce a brief profile of our today's chief guest and keynote speaker, Engineer TV Narasimha Prasad Garu, being called as TVN. Is a practice engineer and entrepreneur. He ventured into innovative business opportunities of contemporary technologies. Presently, he is doing research in IoT and AI technologies, working as freelancer in networking for software companies and data centers, mainly in Bangalore city. He is a founder of IQ at Bangalore. And with this brief profile, now I request our chief guest and keynote speaker to deliver the talk. So please, sir.
Yes. Hello. Yeah, first I would like to thank Mr. Dev Kumar and Institution of Engineers India and Board of Community Development for Education. See, he has given an opportunity to speak on this World Engineering Day on sustainable development. See, there are a lot of opportunities for engineers in this sustainable development field, renewable energy. See, there are a lot of companies worldwide and also nationwide. Those are providing jobs. They are automating all their legacy systems by using artificial intelligence and Internet of Things. See, we can apply these AI and IoT at micro level and macro level. By using this AI and IoT, we can automate systems. By automating the systems, that public will get the benefit and the companies also will get the benefit, and there are lot of job creation is also there in this field. I will show few I will show few snapshots. I will explain about these technologies. Please go through that. One second. See that the introduction to AI and IoT. See, we think this AI is a new and the IoT is new, but actually these are not the new fields. When I did the research, I came to know this AI is there since 1956 and IoT in since 1999. Now we are using this AI and IoT at commercial level. So that I will explain this. See, integration, how we can integrate AI and IoT. Okay. See, what the benefit the companies will get by integrating these AI and IoT. See, first, why renewable energy needs intelligence? Renewable sources are intermittent. Everyone know that solar and wind is variable. The solar is not available 24/7. Wind is also not available 24/7. So that we have to optimize. See, one more thing. See, energy generation is geographically distributed. See, there are national and international companies worldwide. They are having their wind farms and solar farms worldwide. They have hundreds of farms all over the world. See, by using these technologies, AI and IoT, they can connect it to their wind farms and solar farms so that they can control. So that by controlling, they can minimize the cost and then they can make profit by doing this AI and IoT. See, once if they are connected to connected to that, all are interconnected, it will generate lot of data from the sensors. See, and we need predictive maintenance. See, what will happen? The wind farms and solar farms now they are managed by manually. They will manage. That means the need for hundreds of manual employees, those who are sitting at the wind farms and solar plants. Once if it is automated, there is no need of manual labor at the wind farm and solar farms. They can know the condition of the solar farms and wind farms centrally, so that even though no one is there at the solar farms and wind farms, they can know about all the parameters they can get through high speed internet, and they can control, they can predict. Okay. Then grid balancing and demand management. See, what about if it comes to the water? We can store waters in reservoirs. We can use whenever we want. If it comes to the electricity, but we are generating, we can't store electricity like water. Once if it is produced electricity, we have to consume, we have to distribute. So that it is very difficult process. So that if they are all connected to the internet, if they are controlled by Internet of Things and AI, we can balance the grid. I will give one example. See what will happen if everybody uses electricity at peak time, the grid will fail. So that what they will do, they will pay different tariffs. If someone uses that peak time, they have to pay more. If they use non-peak time, so they have to pay less. These, if you want to implement, only if AI and IoT they uses And if they use the smart meters, then only it is possible to balance the grid. Okay, then see, you know very well that reducing operational cost. See, once if it is automated, then the cost will be automatically comes down. See, next, IoT-based renewable energy. Okay, network of interconnected wind farms and solar farms. See, by using this technology all over the world, all over India at state level, all the wind farms and solar farms, we can connect the internet. Okay, sensors collect the real-time environmental data, machine data. See, just like they will generate continuously the data they will generate about temperature, humidity, and many other parameters will be there. By they can monitor if they are connected to the internet. Okay, windmills and solar panels communicate via internet. We know that. Remote monitoring is possible only if they are automated. See, here we are explaining what solar panel temperature sensors and solar irradiance sensors and wind speed sensors and wind turbine vibration and wind detection sensors. Okay, wind wave. Next, what is AI and renewable energy? Machine learning for forecasting. See, if the students, those who are studying engineering, if they know about the machine learning libraries and they can apply machine learning and deep learning for pattern recognition. The pattern recognition means here that every solar panel, instead of manual checking, that through internet, through computer vision, we can check each and every solar panel and each and every wind turbine blades and even wind turbine gear mechanism so that we can predict early failures. See, anomaly detection means the pattern recognition. If there is pattern, we can recognize the patterns. If anything goes out of the threshold, we can control by using the anomaly detection. See, there are optimization algorithms. Once if you have a data by using by using machine learning algorithms, deep learning algorithms, we can optimize the algorithms. See, reinforcement learning for smart control. Reinforcement means the systems they will learn themselves. Once if you feed data continuously, the real-time data, that they will learn themselves. Like humans will learn from our failures, like that the systems will learn if you apply AI and IoT. See, the purpose is converting raw sensor data into actionable decisions. By applying machine learning and deep learning algorithms, anomaly detection, by using optimization algorithms, the purpose is data into actionable decisions. Next, types of automations with renewable energy. Real-time monitoring and automation. Here, the real-time monitoring is most important. See, now these windmills and solar panels are not real-time monitoring. They are monitoring at the site, even though the farm may be so big, but most of them they are not connected to the internet. They are not applying the AML applications. They are not applying AML algorithms. In future, all MNCs and Indian companies they are applying AI and IoT to monitor real time. See that predictive maintenance. If it comes to predictive maintenance, what will happen? These, particularly these windmills are so costly, and even solar panels also. If something goes wrong, there is a huge loss for the companies. If they have the predictive data about their gears and about the blades, windmill blades, and about solar panels, they can save a lot of money by applying AI and IoT. See, energy production forecasting. See, just I told they have farms all over India, all over the world, but This wind may change time to time, wind speed, and also this sun, solar will also that sun intensity will change time to time. So that the forecasting is a big savings for the companies. Now the forecasting is not happening, even though it is happening at their form, but not connected to the internet, not applied AIML. That is like that. And one more thing is battery charge and discharge optimization. We know now all over India, even Western countries also, everywhere, there are big batteries or battery plants are there. The purpose of these battery plants are there to charge the cars and two-wheelers and heavy vehicles. If their battery charging plants are connected to the internet, if you apply AI and IoT, so that they can save money. Because what will happen if it is not connected to the internet, if they are not applied AI and IoT, manually someone has to sit there and they have to manage. So that if they are connected to that, all battery sessions are automated. If they are connected to the internet and applied IoT, there is no need of manual labor to maintain other battery stations. That is one. Automated energy trading. If it comes to the trading means, once they generate the power, these companies, they are selling to the industries and the governments. So that by applying this AI and IoT, they can make huge profits in this sector. See, first we are coming to the IoT architecture in renewable energy. See, sensors. See, sensors means there are many temperatures. All the solar panels and windmills and wind farms and solar farms, they install temperature sensors, vibration sensors, and irradiance sensors. They will implement. They will install. See, they need a edge devices. Edge devices means every solar panel, every windmill, what they will use, there will be microcontrollers. We call it as embedded systems. And each and every solar panel, each and every mill is embedded with microcontrollers. See, what will happen once if you embed it with microcontrollers, then only we can monitor remotely. If it is not embedded with microcontrollers, it is not possible to control remotely. That's the reason we are using microcontrollers. Okay. Now, communication we are coming. See, there is once if they are connected to the internet by using LoRaWAN technology. See, first LoRaWAN means long range wide area network. See, why they are using LoRaWAN technology means if someone has forms, many forms, if they use internet, what will happen? The data charges will be more. Instead of that, if they use LoRaWAN technology, they can connect even 10 kilometers, 15 kilometers. Those who are situated these farms, solar and wind farms, they can connect to the internet. They can save charges. Instead of connecting to the internet, they can use their own LoRaWAN. That is, everyone know about 5G, 6G also coming. That 5G, by using 5G also, we can use for connecting these solar farms and wind farms. And one more technology is there, communication technology, message queuing telemetry transfer. This they are using. See, this cloud platforms we are telling. The cloud platform is, we know that AWS and Azure. AWS is Amazon Web Service. Azure is the Microsoft. These once data is generated from the hundreds and thousands of these solars and wind farms, this data is stored via internet in their cloud platform. That AWS is one cloud platform, Azure is one cloud platform, even GCC we have, Oracle we have, and many private cloud platforms also there. And a analytics engine. Once data is stored, that we have to apply some engines are there. just like by using analytics engines, they analyze the data. And then also what they will do is what that every solar farm, wind farm, they will create a dashboard. Once the dashboard is created, we can see what's happening at the edge. If you want to see what's happening at the edge, there are hundreds and thousands of farms, these solar farms. We can see remotely by using this dashboard. And one more important thing is SCADA. SCADA means supervisory control and data analytics. See, each and every the solar farm, wind farm, if they are connected and by using SCADA, we can analyze and data analytics we can get from SCADA. See, data pipeline for A. See, data pipeline means see data collecting. See, data collection from sensor data. Weather data we are collecting. Once we collect the data, what we will do? We have to process the data. See, we process the data and time to time we clean the data to save the space. Okay, time to time we clean the data and we'll get the real time. Maybe every hour or every 12 hours, 24 hours, whenever we want, we can clean it and we will get the fresh data from the farms, solar farms and wind farms. See that feature engineering. Feature engineering. What are the features engineering means? I will tell you that feature engineering nothing but extracting features and utilizing for the data optimization. These are all many technologies are there that like JSON means Java subject, Java script object notation, structured query language, SQL, these are all databases. And this is the purpose of the feature engineering. See, model training means once if you get the data from the remote solar panels, wind farms, we have to model the data. Once if you model the data, we can extract the features. Without modeling, we can't feed that extract data. See, one more thing, model deployment. Model deployment means once it is a model is model creation for each and every solar farm and solar every solar wind farm. Then only we can deploy the model. For the, every time for every farm, every windmill, we have to create a model and we have to deploy the model. That is the purpose. Okay. And we have to continuously monitor it. See, once this data is collected, dashboards are created, what we have to do, continuously monitoring is possible. See, earlier what we were doing that locally we have to employ engineers, employ laborers to go and check time to time the solar farms and wind farms. That means windmills and solar panels. It's a laborious job. We need lot of labor force and they have to work in that environment. It's very difficult. See, no, so that if you are interconnected to the internet, continuously we can monitor by using AI and IoT by using the internet. AI in solar energy, solar power output forecasting, cloud movement prediction using satellite data, and fault detection in PV panels, thermal image analysis for hotspot detection, smart tracking systems. These are all possible only by applying AI. Without applying AI and IoT, it is not possible to forecast remotely. And even cloud movement also remotely may not possible. Even if you want to control remotely, then you need AI and IoT. Without AI and IoT, locally we can do, but it costs more. Fault detection means without connecting to internet, without AI models, it is not possible for fault detection remotely. If not means locally they have to go for fault detection time to time. They have to go and see the windmills and also solar panels. By connecting to Internet of Things, by applying artificial intelligence, smart cameras, no need to go there physically. That is the advantage of AI and IoT. Thermal image analysis for hotspot detection. See, hotspot detection means that when these solar panels they will get more energy during particular time that they will detect and they call it as a hotspot. Smart tracking system. See, the tracking is smart tracking is nothing but parameters. What is the temperature, wind speed, and heat monitoring. These are all the we can track remotely by using artificial intelligence and also by using Internet of Things. See, once if you connect by using internet, by using artificial intelligence, wind speed we can predict remotely, turbine vibration also, turbine vibration we can analyze remotely, gearbox failures we can predict remotely by using AI and IoT, and by using drones we can inspect the plates by using computer vision technology. See, see AI models used. See, what are the AI models used? We should know. Here we are using linear regression, means simple forecasting. If you want to forecast, that means forecasting means at what speed the wind mills are going to run in few hours and how much that energy solar panels will generate. If you want to know, you have to apply linear regression. Linear regression. See, random forecast. Random forest is applied for fault detection. See, by applying fault detection in solar panel cracks and windmill blade cracks and gear failures, by using random forecast, we can detect the faults. Next, CNN, thermal image inspection. By using convolutional neural networks, there is one software is there, that is convolutional neural network. By applying, we can take the thermal image of these windmills or solar panels. And autoencoders, anomaly detection. If anything goes beyond the threshold, suppose if that solar panel is not generating any power, there will be lot of reasons what the sensors we have installed may not be properly working, or if it comes to the wind farms, what will happen? Even they will go out of that, it will go it generating because of that cyclones and all these things, it will run so fast, then immediately we can detect it. We can take control of that windmill, we can stop it, the windmills remotely, it's possible. See, reinforcement learning means grid optimization. Grid optimization is nothing but if you have data that once you generate the data, if you generate the electric power by using solar panels and windmills, and at what time the public is using, what time the more power is using, what time the less power they are using. By that, we can optimize the grid. That is the purpose of reinforcement learning. See, there are some challenges and limitations also for this AI and IoT based renewable energy systems. See, high installation cost. In the beginning, the cost may be more, but they will get return on investment within 2 to 3 years. They will get the return on investment. ROI will be after 1 or 2 years, maybe 3 years it will take. That is the advantage. The disadvantage part is in the installation cost is high in the beginning. The cyber security risk means that someone may take control. Someone may hack. It may not possible. It may be 1 in a billion. It's possible. Now systems are fully secure. No need to worry about these risks. Okay. Data privacy concerns. See what will happen. What once it is content connected to the internet, that you will get a lot of data generated. This data is stored in the data centers remotely and also locally we store data. This data we have to protect properly. And integration with legacy SCADA systems. See now there are SCADA systems are implemented. Is SCADA as a legacy system. Now we have to implement new technologies to connect these old systems to new technology. We have to transform from SCADA systems. Model drift and retraining. Once the model is not working, we have to drift to the new technologies and we have to retrain. See, it's model drifting and retraining. Time to time, we have to retrain. That is important once it is connected to the internet. Regulatory barriers. Regulatory barriers means that means government regulations, state and central government. What will happen? Sometimes I have a farm in somewhere in the other countries, other states. See that the regulatory barriers that countries getting data from other countries, other states, they may not give the permission. That is the regulatory barriers. See, now we are coming to the career opportunities. See that IoT engineering. See, Internet of Things engineer, IoT engineer we call those who know all these things, technologies and IoT platforms. There is a lot of job opportunities as an IoT engineer. And these multinational firms, they will employ as engineers, IoT engineers, and data scientists also. Once data is generated, the millions of data points, someone is required to analyze this data so that there is a data scientist jobs and machine learning engineer, energy sector. In the energy sector, maybe private sector or government companies all over the world, there are billion-dollar companies are there. Those who are producing this solar power and wind power, there they require many machine learning engineers. And that they are using, just now I told, they are using AWS and Azure platforms and Oracle or Google Cloud platforms they have to use to store this all this data. Then each these companies require cloud engineers and DevOps engineers. That means they are creating there is job opportunities for cloud and DevOps engineers. And there are job opportunities as a smart grid engineer. See, once if they generate data, these MNCs, multinational companies, or national and state level these companies, they manage data. They have their own grids, just like our AP government has a grid, smart grid, and all the state governments they have the grid, smart grids. And like that, these private companies also they have their own grid, and they need grid engineers, smart grid engineers they need, and also drone and robotics engineering. These companies, renewable energy companies, solar and wind farm generating companies, they are employing drones in their solar farms, in their wind farms. There they need drone operators and they employ the robots. They employ robots to clean the server solar panels. To repair the solar panels, they employ the robots. That means at their solar farms, at their wind farms, they need robotics engineers. And those who are studying engineering, maybe first year, let it be second or third and fourth year, if they are, if they know these technologies, and there is a possibility of getting jobs. There are a lot of job opportunities are there in this solar and wind farm. I would like to tell one thing. There is a lot of demand for the electricity because we are shifting from diesel petrol engines, even heavy vehicles also in future is going to run by electricity. That means there is a lot of demand for the electricity, maybe tenfold or fivefold, tenfold will be there. You can see solar farms, wind farms in every village, in every home. It will generate once it is generated. So there are a lot of job opportunities because it's going to increase manifold energy usage. Energy usage increase means many companies will come to give services to generate solar and wind power so that a lot of job creation will be there. See, there are projects. What projects they can do as a students? Solar output production. Once the solar panels they output the energy, we have to predict how much output it is giving. And wind turbines also, we can check the wind turbine, how much that energy is generating, and we can detect the wind turbines gear, any gear faults or any cracks we can detect. That also a project. See, battery health prediction model. See, batteries sometimes fail. There are hundreds and thousands of battery plants are there. We can check their health remotely. That is also a product we can do, project we can do. See, microgrid simulator. See, smart microgrid means there are microgrids are so big, but we can have some small microgrid. We can simulate that microgrid. That is one project. And then IoT-based solar panel monitoring system. See that solar panels are available everywhere. We can buy some small solar panels. We can connect to the IoT. We can monitor so that students can know that how to monitor, how to apply this AI and IoT and all these technologies. And also AI-based energy consumption optimization. And also if any home at home level, at maybe at college level or maybe university level, if we can apply AI and we can see how energy consumption, we can optimize the energy consumption. These are all the projects the students can do. Yeah. Yeah, hello, Mr. Dev Kumar and other students.
Sir,
If you have
yes,
any doubts, can you clarify, please?
Yes, sir. Thank you, sir. Any questions from participants?
hi sir, I have one doubt.
Sir, please, sir. You are audible, sir.
Yes, audible. Yeah.
Actually, sir, you explained about wind energy, right, sir? So there is one model only. They have different type of models, sir, in wind to make the energies.
It's not audible.
Even there was a doubt from one of the participants.
Yeah.
Venkatesh, can you please repeat?
Yes, sir. Actually, he explained about wind, right, sir? There is a one model only to generate the wind power, sir. They have multiple models, sir, to generate the wind.
Yeah, there will be multiple models to generate.
So, so is it possible to take any one model, sir, to generate the electricity in home in low budget? So, making our own experiment.
You are asking about the windmills, or you are asking about the solar panels,
No,
windmills?
no, windmills, not
Yes,
solar, not
yes,
sustainable.
yes. I will share some later. There are new technology came, that is the vertical wind farms. See, vertical. The now the wind farms are horizontal. That what we are using at the commercial level, they are all that what are that horizontal. That wind farms means this is vertical technology is coming. That it will cost cheaper. 1/10 is a fraction of cost. We can make this. You can generate the power. It is in that laboratory level, and some countries is going to implement it. That's a boom for these windmills. That I'll share later about that.
Yeah, please share,
Great
sir.
success in that. Okay, I'll share.
Yes.
Yeah. Sir, any questions about the students or Mr. Kumar? So that I will go through that and I will try to answer.
Yes, sir. Sir, actually, it is very fortunate to have very senior people from IEA have joined.
Yeah,
Captain Bhaskar Bhandarkar from Mumbai has joined here.
yeah.
Professor Dharmalingam from Tamil Nadu has also joined here.
Okay, very
And
nice.
senior IAA member Sujit Banerjee ji from
Okay,
West Bengal are also joined.
okay, very nice, very nice. I'm very happy
Ramnath
to
sir
have.
also joined.
Okay,
Really
okay,
very
okay,
happy.
okay,
Sir,
okay.
some of you can reflect on this session, sir.
Yeah,
Or any other members can also give your reflections.
yeah, please. See, before that, I would like to tell, sir, these what I am presenting all these things is there is a lot of opportunities. Now we are shifting to manual to automation, so that it will create a lot of jobs. So that those who are familiar, those who will learn these technologies, the job creation will be more national and international level in MNCs. Further, students should be ready for this shift from manual to AI and IoT based technologies. They are yes. See, I would like to learn more about if anyone can speak, but I have limited knowledge in this. Still, I am in the research stage, and particularly my field is I am doing research on this artificial and IoT, how to implement in all the fields that I am doing. But anyone can explain about. If you know more about, I want to learn from other people. Those are working in the sectors, maybe windmill or renewable energy.
So there is Professor Loras who is also there. He is heading the aerospace engineering department of Mulready College.
So, thank you, sir. If there are no questions, okay, uh, I request Anil narrator to display the as a token of appreciation for the chief guest. Okay, display online memento and will physically hand over the memento, sir. And Anil, certificate of appreciation,
Okay, sir. I will display.
please display. Sir, as a token of acknowledgement, IAAP State Center and PCDE, please accept our online certificate of excellence, sir.
Okay, thank you very much for giving an token of appreciation.
Physically, we will hand it physically, sir.
Okay. Thank you,
Right.
sir. Thank you so
Right.
much for Mr. Kumar and all the IA and BCD members. I would like to thank once again given opportunity.
Right.
Yeah.
Good evening to you all. It's my proud privilege to propose the vote of thanks for today's insightful and enriching guest lecture. First and foremost, I extend my heartfelt gratitude to our esteemed chief guest and keynote speaker, Engineer TV Narasimha Prasad Garu, for delivering such a thought-provoking and engaging session. Your expertise, practical insights, and real-world examples are truly broadened our understanding of the topic, sir. We are grateful for the time and effort you took to share your valuable knowledge with us, sir. So thank you, sir. And I would also extend my heartfelt thanks to our honorable chairman, sir, Professor Devakumar Garu, immense past chairman, Dr. C.V. Sriram Garu, all the committee members, and the senior IEA members, and especially our electrical division member, Jitendra Gaur Garu, for coordinating the activity. And special thanks to our friend and well-wisher, Dr. Laura Garu, head of the department from FARC, and his students for joining today's session. I would also extend my heartfelt thanks to our IAS staff. So all the IAS staff members and all the other members who directly or indirectly support to mentalize this particular activity. And I especially thank all the participants joining this session and to make the event as a grand. So thank you, one and all. I request Neil to play national anthem, the closing ceremony of this. So thank you, sir. Thank you.
Welcome, sir. Welcome.
We will conclude the session with national anthem, sir.
पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जय गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, sir. Thank you, one and all. Have a nice day. Thank you.
Thank you, TVM, for sharing your time and spite of your busy schedule. Thank
Us
you.
give an opportunity for nice opportunity to give a lecture on this occasion.
Yes, yes.
Okay, thank you.
So, with your permission, we'll keep your session in our YouTube channel.
Yeah, please. Yeah, I'll get it, sir.
Thank you, sir. Thank you very much.
Yeah, thank you.
Thank you, all of you. Thank you, Naresh sir, for nicely organizing.
Thank you, sir.
Thank you, thank you, Anil and team.
Sir, from our side, thank you, sir, Dev sir. Thank you very much for giving this chance for us to hear this webinar. Thank you, sir.
Yeah, thank you, thank you for joining, sir. Thank you.
Thank you.
So, Anil, shall we close the session?
Yes, sir.
Thank you.